All right, good morning and welcome back, fifth graders. This is Mr. Mace again, and I'm here today to walk you through Unit 7, Lesson 4, which should start in your math expressions books on page 309. This is again going to be kind of a kickoff to algebra, starting to get into some algebraic concepts and ideas, establishing things called expressions. A lot of terminologies or things that we really need to kind of either touch back on or review from previous lessons or from things that we have worked on in the past. The big thing that I want to stress in this lesson for us, guys, is that algebra is a lot about patterns and consistencies and creation of those patterns. And a couple of things, obviously, that I want to touch on today for us is the two vocabulary words that are at the top of this page, which are a numerical pattern and a term. And a pattern, I think you guys have been, I know you have been doing patterns since basically kindergarten. Even just counting in general is a pattern. Okay, you're going up by one. So 1, 2, 3, 4, 5 means you're simply going up in consecutive order. That would be a pattern. If you look at the one here on this page, you notice that you are starting with the number 3, but then every number beyond that is going up 2 more than the one previous. So 3 to 5 is going up by 2. 5 to 7 is going up by 2. 7 to 9 is going up by 2. So we would call that a plus 2 pattern. All right? And then every number in that pattern is called a term. Now, what will happen, or where this is taking us in the very near future here, guys, is we are creating numerical patterns today, which is made up completely of numbers. But eventually, we are going to want to establish what we call algebraic expressions or algebraic patterns, where we can start with a variable or start with something like a letter and build off of that using some sort of a rule. So it could be a plus 5 once we establish what that variable is. And so those are the types of things, and that's how we're kind of building that base for your algebraic knowledge. So like I said, the biggest difference here is everything we're going to be dealing with today is based on nothing but numbers. So you're not going to see any algebra terms, but this is setting the stage for an eventual algebra lesson or an algebra concept. All right, so I know a lot of us, if we looked at the pattern here that's in the middle of the page, we would simply call that a plus 2 pattern. And I would agree with that. That is, we are going to add 2 to each number. The problem with that is if I just told somebody, hey, this is a plus 2 pattern, but I didn't give you a starting point, most of you would probably say either starting at 0 or starting at 2, we're going to continue to count by 2s, and it would be our even number. So the really big key to this is understanding where does the pattern start and what is that starting number. And what that's going to get us to, guys, is if we look at this section down below here, we are looking at the fact that we have to start with that number 3. Now, there are two types of expressions. Expressions are simply mathematical sentences, basically, that don't have an equal sign. We don't know what it equals on the other side, and that's because it could change as we progress and how far we want to go with it. Are we trying to figure out the next number in the pattern? Are we trying to figure out the 10th number in the pattern? As long as that pattern stays consistent, we can find any number in that pattern, and that's the big key here. But the other big key is that we have to start with 3 in this pattern, in this case. Now, every number, every pattern we'll go through isn't always going to start with 3, but for us right now it does. Now, one of these patterns could be considered an addition pattern, and we see that right here, starting with the number 3. Every term is simply a plus 2, and it's going to be a plus 2 however many times we are going to add those 2. So for the first term beyond the 3, obviously the 3 is the first term, but the second term is starting with the 3 and adding 2. Okay, and then the third term is going to be starting with the 3 and adding 2 2s. And then the fourth term is going to be starting with the 3 and adding 3 2s, excuse me. Okay, so that's one way. But we also know maybe more efficient ways and other things that are an easier way to write a repeated addition problem. And since it is a repeating pattern, this is the way most of us will start and continue to learn to write these patterns, is turning that repeated addition, the repeated part of our process, into a multiplication problem, and then attaching it to the number we started with. Okay, and this is going to build off of our order of operations that we've worked on in these first couple of lessons of Unit 7, where we can start with our number, but then we're going to include the pattern. And notice again, because that multiplication is inside parentheses, we are going to start with that. Now, if we know of our order of operations anyway, we would always start with the multiplication, because in PEMDAS, parentheses, exponent, multiply and divide comes before add and subtract. So we always would, but I think they're emphasizing the point here by putting those multiplication problems inside the parentheses. Notice also that they're not using the x, and that again is preparing us more for an algebraic concept moving forward, guys. A dot or an asterisk sometimes are also used to represent multiplication. So as we look at this, notice that there's a dot between. That's not a decimal point. That's not some period at the end of a sentence. That is a symbol for multiplication. And the reason we start moving away from the x for the times symbol or the multiplication symbol is because eventually we will start to use x as a variable in an algebraic expression, and now it's confusing. Is that a multiplication symbol or is that a variable? We really want to make sure we understand the difference between the two of them. All right, so if we build past this now, so we've got our pattern established, we understand this is a +2 starting with the number 3. So question 1 says, or question 1a I should say, says write 2 expressions for the next term, the 6th term in this pattern. Okay, and so we've got it started there already. Well, just build upon what we know. So we know we're going to start with a 3. And we said here that this was the 2nd term, and this was the 3rd term, and this was the 4th term. So we know that the 6th term will be after the number 11, okay, and we can almost work backwards here. So we know that 3 plus something is going to get us to 13, which will be our next number. Okay, we can almost jump ahead here to question B and answer that and say we know that the 6th term will be 13 just based on our pattern that we've established. But how might we represent that as a math sentence? How might we write that as an expression? So one way is to do the straight adding. Okay, well, if we've had 3 plus 2, 3 plus 2, 2, 3 plus 2, 2, 2, 3 plus 2, 2, 2, we see that the last one in the pattern has 4 2's, so this one has to have 5 2's to continue the pattern. So here's 3, 4, and 5, and this is definitely one way to represent that answer. All right, the other way is to turn it right into that multiplication, repeated addition problem, with using parentheses. So we're still going to start with the number 3, but inside parentheses we are going to multiply 2 5 times, or we're going to have 5 2's moving forward. And if I do the math, 5 times 2 is 10, plus the 3 gets us to 13. And so that's how we identify those patterns, or how we use those patterns to help us find numbers that we don't see. And it's probably not really difficult, obviously, in a +2 pattern to figure out what the next one would be. But what if we had to figure out what is the 12th number in this pattern? Okay, well, now I need to look at this and say, well, I'm going to start with the 3. I know that. Since the number for the term is one less multiplication symbol, so if I said the 12th term, that means it would be times 11. So 2 times 11 would be 22, plus 3 would get us to 25. So I can tell you right now, without even doing the math, that the 12th term in this pattern will end up being 25. All right, and we can do the math for it and I can show you, but I want this to be a shorter video than that. All right, so now we don't have the pattern to build off of, and now we got to listen to what they're trying to tell us here and show us for question 2. And it says, write the first 5 terms of a numerical pattern that begins with 5 and adds 5. So this is even an easier one in my opinion, because you start with the number 5, it tells you to, and then you're going to add 5. So write the first 5 terms of a numerical pattern that starts with 5. So here's 5 and adds 5. So all we're doing now, guys, is adding 5 to each of these numbers. So here's the 2nd term, 3rd term, 4th term, and 5th term. Pretty straightforward stuff. Now again, I don't really care which expression I'm going to use, but it says write an expression. So I could do the multiplication one or the addition one. I'm going to do the addition one just to show you what that would look like. So we start with the 5. Here would be the 2nd term, 3rd term, 4th term, fifth term, and the sixth term. So again, fairly straightforward what we're looking for here. So we have 1, 2, 3, 4, 5, 6 fives, okay, and that's going to equal 30, and that would be our sixth term would be 30. Another way to write this would be I'm going to add 5 6 times. There doesn't need to be a parentheses in this one because our starting number and our pattern, our repeated addition of 5, is the same number. If we started with 4 and then added 5, it would be 4 plus 5 times 5. So you're going to add those things all together. All right, and that's going to get to question 3 here, where it says write the first 5 terms of a numerical pattern that begins with 1 and then adds 9. So again, 1 plus 9 gets us to 10. 10 plus 9 gets us to 19. 19 plus 9 gets us to 28. And 28 plus 9 gets us to 37. All right, and we keep progressing up there. Now it says write the expression for this. I'm going to do the multiplication one for this one, where it says we start with 1. And then I'm going to multiply. We're going up by 9. So 9. And in this case, it has to be 1 less because our first term is out here already as the 1. So it's going to be 9 times 5 inside the parentheses. And so the sixth term is whatever that ends up being. 9 times 5 is 45 plus the 1. Gets us to 46. All right? And if I put that in the pattern and I skip count by 9s with my already started list, that would be what that would look like. All right? So hopefully that's making sense. Again, guys, I think it's a relatively straightforward, relatively simplistic concept for today, but I do want to put it into what we call a rate table or another table. I'm going to skip a page here because I think that's easy enough. But here is another way that we represent these patterns. And this is actually 2 patterns together where we move this through to try and identify this. And I'm not going to go through all of them, but I'm just going to go through the top one to show us that sometimes we have to understand that there are 2 patterns working together. So if we look at the top box here, this is either called an input-output table, or we also call this a rate table. They go up consecutively. They go up together. The patterns are connected. We can see that if we have one overdue book or 1 day of an overdue book, it's going to cost us 15 cents. And then if we have a second day, it's 30 cents. Okay, so we can see that this is going up by 1 all the way across here. Okay, plus 1. The one down here, whereas this was, let me maybe write it this way, it'd be easier, plus 1. This one is going to be a plus 15, and we started at 15. So 15 plus 15, that means if I go from here to here, it's going to be a consistent pattern again. So plus 15 is going to be 45 cents. If I go from here to here, it's another plus 15, which gets us to 60 cents. And if I go from here, here to here, it's going to be another plus 15, and that's going to get us to 75 cents. Okay? Now, the question is not asking what are our patterns, going up by 1s, going up by 15s. The question is just asking how do we describe the relationship between these 2 numbers? Okay? And if that's the case, we are looking at these numbers as not being addition or skip counting patterns, but how do I get from 1 to 15? What did I do? Now, I could either be adding 14 or I could be multiplying by 15. But the way to check that, or the way to really guarantee that, is as I look at problem number 2, or the second box. If I go to the 2, if I added 14 to that, my number would be 16 cents, and that's not what it is. So it's not an adding pattern. This is a multiplication connection, or a multiplication comparison, meaning to go from 2 to 30, I had to multiply also by 15. So in this case, the rule for this input-output table is times 15. So every time I go up by 1 on the top, I multiply that number by 15 to get my answer. All right? So hopefully that makes sense to you guys, and I think that it should be a fairly straightforward, but if you have any questions, please make sure to reach out to your teacher and ask some questions. Again, hopefully this will make some good sense to you. We're going to put some practice problems together in an exit ticket and put that ready for you guys to do. But I'm excited to see you progress and hopefully get us to a point where we can start putting these into more algebraic expressions and not just numerical. Good luck, guys, and again, don't be afraid to reach out to your teachers.